In one of my recent videos, I talked about general strategies that you want to keep in mind when you're trying to find the domain of a function algebraically. But in this video, I wanted to show you another example of how you can actually apply these methods to find the domain of a specific function. In particular, we're going to be talking about how to find the domain of functions that have fractions in them. And I'm going to show you exactly how to actually do this with a specific function that we're given. So by the end of this video, you should have a much easier time finding the domain of a function that is made up of a fraction, and especially those where your variable of your function is actually in the denominator of the fraction. That's really kind of the key here. So if that sounds good to you, be sure to stick around to the end of the video. And without further ado, let's go ahead and jump right into the example. First thing you want to do is think about the three main limiting factors of the domain of a function. We can never divide by zero. In this case, we actually have a fraction, so we know that we need to be careful about that. We can't divide by zero. So we have a fraction. We need to make sure that this denominator is not zero, because if the bottom of your fraction is zero, that means you're dividing by zero at some point. So whatever x value would make that happen is going to cause a problem, and that should be eliminated from our domain. Other things you want to look out for: you cannot take the square root or an even root of a negative number. In this case, we do not have any square roots or even roots, so we don't need to worry about that one. And then you can't take a logarithm, natural log, or any other base logarithm of 0 or a negative. So in this case, we don't have any logarithms. We don't need to worry about that one. We really just need to make sure that whatever is in our denominator, this whole x squared minus 2, does not equal 0. So we can set up an inequality equation. It's not going to be a greater than or less than inequality. It's going to be one that just says x squared minus 2x cannot equal 0. So x can be, this denominator can be negative. It can be positive. That's completely fine. You just need to make sure that it does not equal 0, because if it does, you're dividing by 0 and you're breaking the rules of math. You can't do that. Can't divide by 0 ever. So keep that in mind. So to solve this, kind of similar to the last example we did, both of these terms here have an x in common, so we can factor the x out. X squared divided by x leaves us with an x in the parenthesis here. Negative 2x divided by x just leaves us with a negative 2 inside the parentheses. So we know this cannot equal 0. Okay. So again, we have these two factors being multiplied. We know that these two factors times each other cannot equal 0. So what we can do is split this up into two simpler equations, because if 0 times any number will give us 0, we need to make sure that neither of these numbers is 0. So we would have x cannot equal 0 and x minus 2 cannot equal 0. As long as we make sure that both of those are true, we should be good. So this one's already solved for. X cannot be 0. This one we can just add 2 to both sides, giving us x cannot be 2. So as long as x does not equal 0 and x does not equal 2, we should be fine. So to write this in interval notation, that basically means that we can have any x value between negative infinity and 0. We do not want to include 0 in our interval, because if we do, we're going to divide by 0. So this is going to be a round parenthesis. Then we're going to have the union of that interval, and then the interval that gets us from 0 to 2. So 0 to 2. Again, these are both round parentheses here, because we do not want the endpoints of these intervals included in our domain, because the endpoints is what causes us to divide by 0. Every number in between there is completely fine. Then the union of that interval and the one that goes from 2 to positive infinity. So this kind of three-segment domain, these three intervals, the union of those three intervals is going to be the domain of this function, because 0, x equals 0. So the one little number basically that's between these two intervals and the one little number that's between these two intervals are the only two x values that cause us to break the rules of math when we plug them into this function. Therefore, they need to be removed or left out of our domain. But all the other x values are completely fine, because they're not going to cause us to divide by 0. That wasn't so bad, right? I think that was a really important example for you to see, because there are a lot of other functions that are similar to that are going to apply the same process and same concepts. However, there are a lot of other functions that work out very differently than that one when you're trying to find their domain. I have made another video that talks about a blueprint that you can apply to basically any type of finding the domain of a function problem. So go click on that video right there. So you can nail down that topic, and finding the domain of any function should be a lot easier for you after that.